Welcome to the second video of this week, 6.1, and we're going to be doing factoring for the first time. And you don't even get to see me do it in person. I know, I'm sad too. I'm sad that I don't even get to see my students for the rest of the semester. I didn't realize that until, a couple weeks ago. And then somebody else just showed me today that we're not even going to get out for summer. So, hope everybody's doing okay. I really am. So here's the thing with factoring. We have two techniques in this section. One is GCF, and the other one is grouping. GCF and grouping. Now, GCF is finding the greatest common factor. So if you look at your notes, you can see some examples of what it means to find a greatest common factor. When you're looking at a polynomial like this, you need to kind of underline each term. This is what I like to do. Every time I have a factoring problem, I like to underline each term. It lets me see them separately. In each term, I'm going to look at the numbers in front, the coefficients, and I'm going to ask myself, do they have a number in common that divides evenly into both? In this case, there are several. 3 goes into 30 and 3 goes into 15. 5 goes into 30 and 5 goes into 15. 6, yes, no. So 6 would be out. And then we have 10, no. 10 doesn't go into 15, so that's out. And then we have 15, yes. So of all these numbers, which we have the GCF, we got 3, 5, and 15. Those are all numbers that work. We want the biggest one, and that's 15. And that is my GCF. Now, what I do is when I write the answer, I always write my GCF, and then I write a parentheses, an open parentheses. And you don't have to close the parentheses until you're done writing in case you're, weird about spacing, like I am sometimes. Because I've done this enough that I know the spacing now, I think. Or I'm not so weird about it. Whatever. Anyway, so with numbers, you always want to find a number that goes into both of them evenly, and you want to pick the largest one. So it might help to list them out and then circle the biggest one. For letters, though, you want to take any letter that they have in common, and you want to take the one with the smallest power. Now, in this case, they don't both have x, just him. He doesn't have x. So we can't put an x in our GCF. That would be wrong. So just the number. What goes inside the parentheses? Well, that's what you get when you divide each one of them by 15. And now you can see that not only does my underlining let me see these terms separately, but it also gives me a little place for me to divide. Cool, huh? Anyway, 30 divided by 15 is 2. Don't forget your x. Plus 15 divided by 15 is 1. Don't cancel and not write a 1. Very important. And your answer is this, the GCF and the thing you get when you divide. Okay? Let's do that again, and again, and again, and again, and again, and again, and again. Here's a problem where they have an x in common, but they don't have a number in common. 2 and 7, they don't have anything in common. So there is no number in our GCF. And you don't have to write this little GCF thing here. I just like to sometimes. I didn't underline. Oops. Okay. So they don't have a GCF number, but they do have a letter in common, x. And you want to take the one with a smaller power. And that's x to the 5th. There's your GCF. Now I'm going to open up a parentheses. And then I'm going to divide both of them by x to the 5th. Sorry if that's small. But the x to the 5ths cancel in that first group, just leaving you with 2. And here, the x to the 7th divided by x to the 5th means you're going to subtract 7 minus 5 and get 2. So it's funny, you can't do this factoring business until after you learn about subtracting exponents. See, we all do this in the right order. It's like we know what we're doing. Hopefully, by the end of this, you'll know what you're doing. But it's the same process. We found the GCF by looking at the numbers and then the letters separately. And then we divided both of those terms by the GCF. And that's what we got. Here we have number 3, 2. Oh my God, I did number 3, didn't I? Oh, nobody's here to correct me as I go. There they go. That's number 3. This is number 2. Here we have 8. That's why you don't use pen, Greg. 8x to the 8th y minus 56x to the 6th. All right, underline, underline. Here we got multiple letters, but they only have one letter in common. Now, before we get to the letters, let's look at the numbers. 8 and 56. What do they have in common? Well, they got 2 in common, right? They're both even. They got 4 in common. 4 goes into him, I think. Yeah. Yeah. And then they also have 8 in common because 8 goes into 56 evenly. I want 8. So here's my GCF. GCF is 8. And then they both have an x, so I'm going to put an x in there with the smallest power. That's 6. They don't both have a y, so do not put a y in the GCF. It's time to open up a parentheses. Now I'm going to put the 8x to the 6th. Whatever the GCF happened to be, I'm going to put that underneath. I'm going to divide. 8's cancel. 8 minus 6 is x squared. And then don't forget your y. 56 divided by 8 is 7. And then the x to the 6's cancel. So there you go. That's it. See, I don't always get the spacing right. That's GCF. We're just getting used to it. Sorry we're going out of order. You know. It don't really matter. 25x to the 3rd y plus 45xy to the 4th. Now here is a problem where we have common numbers and common letters. Just like here, but you know, we had a uncommon letter, y. Here they both have x and they both have y, and that's interesting. So with 25 and 45, let's see, 5 goes into both. And that's it. Right? Well, 5 times 45 is 9. 5 times 5 is 25. If you're ever curious, and here's a trick. If you're ever curious as to whether or not two numbers, you pick the biggest number that goes into both of them, why don't you divide each one of them by the number you think it is? So 25 divided by 5 is 5. 45 divided by 5 is 9. And then look at what you got up here. 5 and 9. Do they have anything in common? No. So you picked the biggest number. That was a good GCF. Now, if this had been 5 and 10 or something, then you would have had to go back and pick a bigger number than 5. Okay? Anyway, this is just a little test in case you're worried that you didn't pick the biggest number. Like here, I was kind of worried, and then I checked, and I was like, oh, okay, it's fine. All right, so now we got x's. We got x to the 3rd and x to the 1st. I want x to the 1st. We got y to the 1st and y to the 4th. I want y to the 1st. Okay? So yeah, it's okay to take the x from this term and the y from this term when you're picking your GCF. It's whatever is the smallest power. Open up a parentheses. I'm going to leave that. Spacing issues. All right, and then we're going to divide by 5xy. 5xy, whatever the GCF happens to be. In this case, I get 5. And then I get 3 minus 1 for x squared. And then the y's cancel. Here I get 9. I did that already. And then the x cancels. And then 4 minus 1 is y to the 3rd. I'm all done. All right. Number 5. We can do it for 3 terms as well. Finding the GCF for 3 terms just means we have to find a number that goes into all 3 numbers. And then we're going to look for the y that has the smallest power in all 3 terms. So when I'm looking at 14 and 4 and 8, I could just look at 14 and 4 at first and go, what do they have in common? 2. 4 doesn't go into 14. And that's the only 2 factors that 4 has, 2 and 4. And by the way, I'm not including 1. 1 doesn't do anything in this. And so then I look at between 2 and 8, now that I have his GCF, and it's 2 again. So 2 is the only number that works for all 3. So he's in my GCF. Y, I have 1 with y to the 1st, so he's the smallest power. He's my GCF. Again, you don't have to write GCF underneath here. I just like to have it just so that I know what this is in case I get distracted and then come back and look at it and go, what the heck is that? You know? Anybody ever do that? Oh. Nobody? Oh, well, that's right. You're not in front of me. I can't see you. 14 divided by 2 is 7. 3 minus 1 is 2. Minus. 4 divided by 2 is 2. 2 minus 1 is 1. Plus. 8 divided by 2 is 4. Y's cancel. Close it up. That's the answer. Whee. I don't want to get confused. Oh no, my computer went dark. Oh, I got it back. Okay, we're good. Number 6. We have 32 x to the 8th, y to the 7th, minus 20 x to the 4th, y to the 4th, minus 36 x squared, y squared. There you go. Okay, so 3 terms again. 1, 2, and 3. I gotta find a number that goes into all 3 of those numbers. And you might be like, oh, so much work. Well, just start with 32 and 20, okay? Just those 2. And then say, what goes into both of them? We got 2. They're both even. We got 4. 4 goes into 20, and 4 goes into 32. 5, not so much. 6, no. 7, no. 8, no. 10, no. Not 32. 20, no, not 32. Okay. Looks like it's 4. All right, so then we go, what's 4 and 36? What do they have in common? It's 4 again. So it's 4. And again, if you want to make sure, go ahead and divide each one of them by 4 and write it above. So 32 divided by 4 is 8. 20 divided by 4 is 5. And then 36 divided by 4 is 9. 5, 8, and 9, they don't have anything in common. So you picked the right one. All right, now let's go to the x's. X squared is the smallest power. And let's go to the y's. Well, y squared is the smallest power. All right, so we're dividing each one of them by 4x squared, y squared. 4x squared, y squared. 4x squared, y squared. 32 divided by 4, we did that. 8. 8 minus 2 is 6. 7 minus 2 is 5 for the y. All right, and then we have 20 divided by 4. We have x to the 4 minus 2, x squared. And we have y to the 4 minus 2, y squared. And then we have 36 divided by 4 is 9. And then x squareds cancel, y squareds cancel. So it's just 9. Hey, there's the answer, all done. Lovely, ain't it? All right. One more GCF problem, and then we'll move on to grouping. 24 m to the 9 plus 36 m to the 7 plus 84 m to the 4th. A little change of pace from x and y, huh? So we got numbers and letters, just m's though. And we're looking at the numbers, again, it's going to be a little difficult to figure out which number goes into all 3 evenly. So let's just start with the first 2, the smaller of the 2. Let's say 24 and 36. And then I go, okay, what do I think? Let's see, 2 goes into both, they're both even. What about 3? 3 goes into him and him, so 3 is bigger. So we got 2, we got 3. What about 4? 4, yes. 4, yes. So 4. 5, no. 6, yes, and yes. So 6 is a good one. 7, no. 8, yes, and does 8 go into 36? No, it doesn't. 32 and 40, but no. So 8's out. 9, no. 10, no. 11, no. 12, yes. Ooh, 12. I got a bigger number. I think that's the biggest one. I'm getting tired. All right. Hey, if you want to make sure, divide each one by 12, and we get 2, and we get 3. Yep. So they don't have anything in common, so 12 is the good one. And then look over here. Does 12 work for 84 as well? Let's just do a little calculator work. Boop, 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 boop. Yes, it does. And look, 2, 3, and 7, they don't have anything in common. 12 is your number. Now, if you picked a smaller number, you're wrong. But you can check by just dividing each one of them by your smaller number and seeing that what you have left over have something in common. And that would be telling you, hey, go back, pick a bigger number than the one you picked. Okay? Now let's look at the letters. M974. 4 is the smallest one. He's the one. Open up a parentheses. And then we write 12m to the 4th, 12m to the 4th, 12m to the 4th, because that's your GCF. Divide, we get 2. Subtract, we get m to the 5th. Divide, we get 3. Subtract, we get m to the 3. Divide, we get 7. Subtract, oh, cancel. And we get no m's for that last one. Okay? And that's factoring using the GCF. And if you feel pretty confident about that, that's great, because GCF happens a lot more often than any other factoring technique, especially grouping. Now, grouping uses GCF when you're doing it. I'm sorry about this chair. It's squeaky as heck, but you know what? It's the only chair I got until that stimulus check hits. And maybe I'll get myself a new chair. No, I won't. I'm gonna spend it on other things. I'll be like, I can still sit down in this chair. I need that money for something better. I don't know. Whatever. Here's grouping, okay? So grouping works with 4 terms. I got 1, 2, 3, 4 terms, okay? And there's no GCF for all 4, right? They don't all have numbers. They don't all have letters. So there's no GCF. But if I have 4 terms for you guys, you can split this up into 2 and 2 like this, right? And what this does is it creates 2 different GCF problems. So over here, for getting this stuff, you can see that they have an x in common. So we're going to pull the x with a smaller power, x to the 4th, and that's the GCF. And then we're going to open up a parentheses, and we're going to divide those 2 terms by x to the 4th, just like GCF. So subtract, we get x to the 1st, cancel, and we get 1. Don't forget to write 1. That's important. All right, now, I'm done with that side. Cover it up. Look at this side. They both have a 4 in common, so that's my GCF. And they don't both have an x, so there's no x that goes with them, so it's just 4. And I'm going to divide both of them by 4. And I'm going to get x minus, again, 1. Oh, look at what we have here. So on these 2 sides, they both have a parentheses that is the exact same thing. That's what we're looking for. So if we do this and we have 2 parentheses that are the exact same, we're going to write our answer as 2 parentheses, the common one and a new one. So this is x minus 1. So both of them kind of become 1. And then we have leftovers, x to the 4th plus 4 that get put together in their own parentheses, like so. So factor by grouping ultimately ends with 2 parentheses like this, with 2 terms each. That's what we want. And the way we do it is we split it up, we do GCF for each half, and then we see that they have a common parentheses, and that's one of them. And then the GCFs that we found, those get put together, and that's the other. It works like that every time, like magic. Number 9. So 10x to the 4th plus 15x squared minus 4x squared, right? Squared, yeah. Minus 6, okay? So I got 1, 2, 3, 4 terms. I look at them all and I say, did they have a number in common? They don't have a letter in common. This guy doesn't have a letter. But do they have a number in common? Well, let's see. Maybe 2. 2 goes into him, and him, but not him. Maybe 3. Nope. Maybe 5. Yes, yes, nope. So they don't have a number in common. So moving on. You got to check, you know? You got to look and see if there's a GCF for all of them before you start splitting it up and doing factor by grouping. GCF is like the master key in factoring. It's the one you always check first. On the left side, we have 10 and 15. Hey, they have a common number. That's 5. X squared and x to the 4th. Hey, they both have x. The smaller number is 2. So there's your GCF for the left side. And I'm going to divide each one by 5x squared. 10 divided by 5 is 2. 4 minus 2 is 2. Plus 15 divided by 5 is 3. X squareds cancel. Done with the left. Moving on to the right. I like to cover it up. -4 and -6, they both negative, so I'm going to make my GCF negative. But they both have a 2 in common. Not 4. 4 doesn't go into 6. So they don't have an x, so this is it. This is the GCF. I'm going to open up a parentheses next to him, and I'm going to divide each one of them by -2. And that's the GCF. Now, 2 negatives make a positive. 4 divided by 2 is 2. Bring down the x squared. 2 negatives make a positive again, and 6 divided by 2 is 3. Well, looky what we have here. 2x squared plus 3 is in common. So that's what I'm going to write once. And then I'm going to write my leftovers, 5x squared, and this -2 together like so. Right? Okay, so just make sure you understand. 5x squared comes from him, -2 comes from him. Number 10. Is it the last one? Yes, it is. 3x squared minus 6xy plus 2xy minus 4y squared. Except for that one time where I screwed up. I'm not doing so bad with pen, right? Eh? Not too bad. Just, patting myself on the back. Okay. 1, 2, 3, 4. Oh, this is grouping. Do they have anything in common? No. 2 doesn't go into 3, and 3 doesn't go into 2. They don't all have a y. He doesn't. And they don't have an x. He doesn't. So now you might look at this and go, wait, these two middle terms, like this last problem, could have combined. But that would have given me a 3-term thing. And we haven't dealt with that yet. That's next week. So let's keep doing factor by grouping. Split it up. Find the GCF of the left side. We got 3. And then they both have an x, and the smaller power is 1. They don't both have a y, so don't include that. Divide by 3x. Divide by 3x. 3's cancel. We get x. 6 divided by 3 is 2. X is canceled, but we still have a y. So bring him down. Okay? Cover it up. 2 is in common. Y is in common. They don't both have an x, though. Y the first. So I'm going to divide by 2y out of both of them. And the 2's will cancel and the y's will cancel. We'll be left with x. Minus 4 divided by 2 is 2. 2 minus 1 is y to the first. And it's happened again. Common parentheses, x minus 2y. I'm just going to write that one time. And then my little leftover is 3x and 2y. Don't forget, if this is positive, put a plus. That'll keep you from writing 3x, 2y, or even worse, multiplying them together, which is wrong. But there you go. And that's the end of that little tutorial. I hope this helps.